Hello everyone, today we are going to discuss about secant method. The programming language we are using here is MATLAB. The prerequisite for this video is an idea on Newton's method. What is secant method? Suppose that we are given with the problem of finding optimizer of a non-linear function f of a single real variable x. Then secant method can be used to find the optimizer of the function. Secant method is preferred in place of Newton's method because of the ease of finding the optimizer without using second derivative of the function. As Newton's method fails to converge towards the optimizer if f double dash of x is less than 0. It is an easy way to find the optimizer of a function with good accuracy and can be used where second order derivative cannot be computed or forbidden to use. Generally, this method is used for higher order nonlinear equations where finding the optimizer is the task. Secant method uses the secant joining kth and k minus 1 point to find the optimizer at the k plus 1th value. For finding from Newton's method, we can deduce the first order. We can deduce the given equation as x of k plus 1 equals to x of k minus f dash of x of k by f double dash of x of k. This can be derived from first order necessary condition, as we should be familiar about it. If the second derivative is not available for finding the optimizer, then we may approximate using the first derivative information. In particular, we may approximate f double dash of x with f dash of x of k minus f dash of xk minus 1 by xk minus 1 xk minus xk minus 1. We have to replace f double dash of x with the given equation so that we can use first order derivative in place of second order derivative for finding the optimizer using secant method. Now, on substituting f double dash of x in the above equation, we can eliminate second order derivative from the equation. Then we will get the above equation. We can use this equation to find the optimizer value, that is either minimum or maximum using secant method. The below graphical representation indicates the convergence of the value towards the optimizer. This is performed by guessing two initial values within the domain of f of x. By observing the graph, we can say that while the secant joining the 2 points, that is x of k minus 1 and x of k, gives the value of x of k plus 1. That is, it is converging towards the optimizer. Now let us discuss about secant method algorithm. Steps of algorithm. Initially, we have to choose two initial values x0 and x1, such that f of x0 and f of x1 have opposite signs, and their product, that is f of x0 and f of x dot f of x1, should be less than 0. Calculate the secant line passing through x of 0 and f of x of 0 and x1 comma f of x1. That is the slope of the given line is f of x1 minus f of x0 by x1 minus x0. Now calculate the x-intercept of the secant line. If the difference between x2 and x1 is smaller than a pre-specified tolerance value, then stop and return x2 as the maximum or minimum value. Otherwise, set x0 equals to x1 and x1 equals to x2 and repeat the same procedure. That is, this describes the secant method algorithm. Now, let us observe the code. Initially, we are taking a function f. Here we are taking x cubed minus 12.2 x square plus 7.45 x plus 42. Then we are guessing two initial values, x1 and x2. Then we are giving a tolerance value such that the tolerance should be followed. We are setting the maximum number of iterations here, that is 20. Now we are running a loop such that we are calculating the intercept of the secant, that is the point at which the secant line touches the x-axis. Now if the given value is less than the tolerance value, then we have to update the previous values, that is x1 equals to x2 and x2 equals to x3, where x3 is obtained from the previous equation, that is x of k equals to x of k plus 1 equals to x of k minus f dash of xk by f double dash of xk, where substituting f double dash of xk, we can now we have to substitute f double dash of xk in the given equation to get x3 value. Here we can observe the table, that is we are entering the initial value x1 is 13 and then the initial value x2 is 12. We are entering the tolerance value 10 power minus 1 and the maximum number of iterations are 5. And finally the root is approximately 11.2. Now coming to the applications of secant method, we are discussing the applications based on machine learning. This can be used in nonlinear regression, that is in machine learning. During the procedure of nonlinear regression, we can use secant method. To expand on the application of the secant method in nonlinear regression, let's consider a simple example. Suppose we have a set of data points x comma y, and we want to fit a nonlinear equation f of x comma a comma b to the data. That is, we are fixing a given data point to a given nonlinear function. That is nonlinear regression, where a and b are the parameters that we want to estimate. The function f of x comma a comma b can only be nonlinear functions such as a polynomial or an exponential function. To fit the function to the data, we need to minimize the sum of squared errors, that is SSE, between the predicted values of the function and the actual values of the data. The SSE is given by the below equation. To minimize the SSE, we need to find the values of a and b that minimize the derivative of the SSE with respect to a and b. This is equivalent to finding the roots of the following system of equations. That is, we are partially applying the derivative to the given SSE, that is dou SSE by dou A. We will obtain the above equation, and dou SSE by dou B we will obtain the given equation, where the secant method can be used to find the roots of this system of equations. The algorithm starts with an initial guesses for the values of A and B, and then iteratively updates the guesses using the secant method formula, that is x of k plus 1 equals to x of k minus f dash of xk by f double dash of xk, where we have to replace the double derivative with the supplement of single derivative. Here, f of an and f of bm are the values of the left and values of the left hand side of the equations at the current guesses, and f of a of n minus 1 and f of b of n minus 1 are the values at the previous guesses. The algorithm continues to iterate until the difference between the current and previous estimates is smaller than the tolerance value. That is, we are checking whether the error should be less than the tolerance value or more than the tolerance value. In summary, the secant method can be used to find the roots of the derivative of the SSE with respect to the parameters in nonlinear regression problems. This helps in finding the values of the parameters that minimize the SSE and provide the best fitted model to the data. This is the application of secant method in machine learning. Limitations. Now we are going to discuss about limitations of secant method. If the function has a vertical asymptote or a discontinuity in the interval between the initial guesses, the method may fail to converge. That is, the function should be continuous. It shouldn't be discontinuous, and there should be no asymptote. If the function has a flat region or a small slope near the root, the secant method may converge very slowly or not converge at all. The function should be unimodal. That is, in ideal condition, the function should be unimodal, not a flat region. The function shouldn't be flat. If the initial guesses are very close to each other, the method may not produce a meaningful approximation of the root. As the points are very close to each other, the secant may not convert to the minimizer very fastly. If the initial guesses are too far apart, the method may overshoot the root and diverge. That is, if the guesses are very far, then the secant may overshoot. That is, if it does not intercept x-axis or it does not touch x-axis within the bounded region. If the function has multiple roots in the interval between the initial guesses, the method may converge to a different root or not converge at all. If there are multiple roots for the given equation, then we cannot use secant method. In general, the secant method is most effective for the functions that are smooth and have a relatively simple shape in the vicinity of the root, and for the initial guesses that are reasonably close to the root. If these conditions are not met, other root finding methods may be appropriate.